Good morning all. My name is Dr. Priyanka Pradhan. I have completed PhD in carbohydrate chemistry from IIT Guwahati under the supervision of Dr. Pawan Kumar Kancholla. My thesis title is Design and Development of Stereoselective Methods for CO and S glycoside synthesis utilizing sterically straight nitrogen bases and cyclic sulfonium salts. My thesis contains 5 chapters. I will discuss one by one. In my PhD journey, my main motive was to design a simpler catalytic system for achieving stereoselective glycosylation reaction. These are some well-studied bulky pyridine derivatives. If you see the pK trends from pyridine to choline, pK value gradually increases, but from choline to TTBPY, pK value decreases. This weak basicity is due to the poor solvation in aqueous medium. If you see in the nonpolar medium, formation of contact ion pair, but the hydrogen bonding between this cation and anion is not possible due to these bulky tert-butyl groups. So this ion pair become frustrated and gives rise to unusual reactivity. So inspired by this distinct reactivity, we thought that can it catalyze glycosylation reactions? After that, we have designed a phenol-based organocatalyst incorporating cyclic sulfonium moiety as a charge term, which is stabilized by intramolecular charge stabilization. In this chapter, we have designed a novel methodology for the synthesis of 2-deoxyanoline glycoside utilizing 2,4,6 tritarbutylpyridinium hydrochloride salts. It afforded the product with excellent yields with alpha selectivity. For synthetic application, we have synthesized this pseudodisaccharide 2 and this propagyl and alcohol containing aniline glycoside 3 from 1 using palladium catalyst Heck and Sonogashira coupling. It afforded the product with excellent yields and alpha selectivity. When we have performed the reaction using deuterated oxygen, then 70% deuterium has incorporated, which is cis to the oxygen. This suggesting that this is the concerted addition of OD bond to the glycyl. In this third chapter, we have developed a novel methodology for the synthesis of this O and A septanoside using phenolic cyclic sulfonium moiety as a charge term. Here we have used this 3-oxohydropropane donor and we had varied several catalyst, and here we have used a variety of acceptor. Here we have synthesized this trisaccharide 6 from this 4 using TBF, then deproduction of the disiloxane protecting group, and here we have used this diol in our glycosylation reaction, and it afforded this product 6 with 62% of yield with alpha selectivity. Also we have used synthesized this C2-disaccharide 9 from the 7 using palladium catalyzed Sonogashira coupling. The beauty of the catalyst is it activates the donor and acceptor simultaneously. In this fourth chapter, we have synthesized this alpha RLC glycosides using palladium catalyst Heck coupling reaction. Here we have used first time proton sponge which act as a reductant ligand as well as organic base. Also, we have synthesized this beta RLC glycoside from alpha RL glycoside using 20 mole % TTP chloride. When we have mixed this palladium acid and proton sponge in equimally ratio, then formation of this red complex, and we have characterized this red complex using HRMS and UV analysis. When we have used this red complex in our this reaction, it afforded the product with 10% of yield with alpha selectivity. And to check the role of palladium 0 in this catalyzed reaction, we have used 6 mole % palladium 2 dBA whole 3, but in this case also we got the product with alpha selectivity. So this reaction clearly tells us that this palladium proton sponge complex is this active catalytic species in this current transformation. In this fifth chapter, we have developed some heteroatom containing sterically hindered non-nucleophilic bases which is structurally similar, can be prepared easily, affordable cost, and we have studied their difference in chemistry arising due to this structural modification at the ortho position. If you see, there are 4 possible conformations possible, but from crystallographic structure, this no hydrogen bonding interaction conformation is the most dominant conformation. In case of methyloxy triplet salt, there are 3 possible conformations possible, but from crystallographic structure, due to static effect, this is the 2 hydrogen bonding interaction is the most possible dominant conformation, and this study provides the influence of this Thorpe-Ingold effect. Here, this NH anion distance in all the substrates much longer than the usual range of 1.9 angstrom, and this deviation reflects the poor ion pair stabilization in this hindered salt, which is similar to like TTBP salt. Also, we have performed several NMR titration experiment, and from it concluded that AOT compound is more basic than TTBP than methoxy 1. And then also benzoyloxy salt is this more or less basic than TTBP salts. Thank you everyone.